Dear students, now today we are going to study quadratic formula to solve the quadratic equations. I hope that all of you must have watched the video of solving quadratic equation by factorization and its general form, its standard form, and what do we mean by solving the quadratic equations, how do we frame quadratic equations in our daily life problems. If you have not watched the video, please watch it, and because it is made for you to understand the topic that are given in the NCERT textbook, and watch the video thoroughly. After this, you had solved some questions based on factorization, and now today we are going to learn quadratic formula and its geometrical interpretation. So it's a very important formula, quadratic formula, to solve the quadratic equations. We can solve any type of quadratic equation by using this formula, because factorization method and graphing method of solving quadratic equations has some limitations. As in factorization method, if we have irrational roots, then it cannot be factorized into linear factors simply. So quadratic formula is a very efficient way of finding the roots of any quadratic equation. Now, going back to the history, the solving of quadratic equations is often credited to the ancient Indian mathematician. We should be very proud. The first mathematician was Brahmagupta. He gave an explicit formula to solve this type of quadratic equation, that is ax square plus bx equals to c. And later on, another Indian mathematician, Sridharacharya, he derived the quadratic formula for solving a quadratic equation. So we'll be studying its geometrical interpretation and its use. But before doing this, let us once again revise the topics, the quadratic equation, and watch the previous video that I had sent before. Now, geometrical interpretation. Now let us say if we have a quadratic equation of the type x square plus 2x equals to 15, and we want to find out its solution. We are doing it by completing the square method. What is completing the square method? It means that let us represent these terms by some geometrical shapes. Now x square is represented by a area of the square of side x units, and 2x is represented by a rectangle. 2x is represented by a rectangle of length x and breadth 2 units, and it is equal to the geometrical shape having area equals to 15 units. Now we have to find out the length of the side that satisfies this, that both the areas in the left hand side is equal to the area in the right hand side. So how do we do this? Let us break this rectangle into two parts, equal parts, where we are dividing it by 2 unit length into 1 unit each, and we are getting this type of two rectangles. Now what we are doing now in the next step? In the next step, we will arrange these rectangles. We will arrange these rectangles on the upper side like this, one, and on the on the right side of this square. So what we are left with now, it is almost, the shape is of almost like that of a square, but only one thing is left, that is this area, that is 1 unit square. So this area will have to add to make it a complete square. Now you can understand this. First we had this area of a square, that is x square. We arranged two rectangles, one in the right side, one on the top side, and it is just short of a square by this area of 1 square unit. So what do? We add this unit square here, and because these areas are equal, so we'll have to add one area, 1 square unit, to the right hand side area also. So 15 plus 1 will be equal to 16. As you can see this figure now, this figure is totally square. Now this figure becomes a square, and what is the side of this square? You can see that it is x, total length will be x plus 1. x plus 1 here at x plus 1 because it is a square. So area of the square will be side square. So side is x plus 1, so it is x plus 1 whole square, and this area is equal to the left hand side area, that is 16. So x plus 1 whole square is 16. That means we can get this area either by two ways. So one will be when the length is positive plus 4, when the length is, let us take, minus 4. So it will be square root, taking square root we have x plus 1 equals to 4 units, and by transposing we have x equals to 4 minus 1, that is equals to 3. Similarly, if we have the length of minus 4, because minus 4 into minus 4 also gives 16, and plus 4 into plus 4 also gives 16. So we take minus 4 here, transposing we have x equals to minus 4 minus 1, it gives us minus 5. So in this way, geometrically we have found two roots, x equals to minus 5 and x equals to 3 here. So this is the meaning. Now we will use the same method to in the general form, in the standard form of the quadratic equation. Let us take this. It is like you can say ax square plus bx plus c, and what we have done over here, we have just taken this constant term to the right side, ax square plus bx equals to minus c. Now we have divided it by the coefficient of a. So it is x square plus b by ax is equal to minus c upon a, dividing throughout by a. So again it becomes comparable to the equation x square plus 2x equals to 15. So we are going to do it in the same way. It is x square plus 2x equals to 15. We can compare this. So moving on, we have this geometrical representation. Here we have a square of side x units, and we have a rectangle of side of length x units and breadth b by a units, as in the case of x square plus 2x. Now what we did in the next step, the right hand side area was equal to the minus c over a. It was equal to 15 in the previous question. Now it is equal to minus c over a. So what should be done? What should be the length of x so that both the areas give us the same values? Let us again split this rectangle into two parts. So equal two parts will have the length as x and breadth as b by 2a units. We have two rectangles here. Again, by arranging them in the same way, one on the top side and one on the right side, this figure almost becomes a square, but it is short of this one. So we are going to add this square of side b by 2a. Because we are adding it on the left side, so we have to add it on the right side also. So the square area, that is minus c upon a plus b square upon 4a square, we add to the right hand side also. Now what is the side of the square? It is, you can see, it is x units up to this mark, and after this b upon 2a. So the total length will be x plus b upon 2a. So this square, the area of the square will be x plus b upon 2a whole square, and area of right hand side will be equal to minus c upon a plus b square upon 4a square. So we can compare this, and we can write this in the form of minus c upon a plus b square upon 4a square. Simplifying, we have, by taking LCM, it is 4a square, so minus 4ac plus b square. Now x plus b upon 2a whole square, x plus b upon 2a whole square, we have this one, that is x plus b upon 2a whole square equals to b square minus 4ac upon 4a square. Now when we take the square root, we have x plus b upon 2a, and the square root can be of plus and minus sign, plus plus into plus, and minus minus is also plus. So we have two square roots, one with a positive sign and one with a negative sign. So by transposing this term, we have minus b upon 2a plus minus under the root b square minus 4ac upon 2a, and x equals to minus b, combining it, plus minus under the root b square minus 4ac upon 2a. So this is our very important quadratic formula, and it is the master formula to solve quadratic equations of all types, where a, b, c are real numbers, a is not equal to 0. Now how do we remember this quadratic formula? And there is a story about it. You can remember and memorize this formula by using this, that there was once upon a time there was a b you can write with a small letter, that is small b. She had many friends, and once she was invited to a radical party. Radical, we can say it's about something, some idea belonging in a particular idea, and radical sign in mathematics, it denotes square root. But she negated to go to the party. Negated, we can use a negative sign. And though later on she thought about going to the party but could not decide. So could not decide will have plus minus sign. Now at last she went there. Some square bees were playing cards. Square bees means b square, and they threw down 4 aces from the cards. Threw down means minus sign, and 4 AC, 4 aces, and the whole thing or the party was over at 2 a.m. So 2a, the whole thing, it means like this. We have B, and you can see here B, and she was invited to the radical party, and but she negated, negative sign. She could not decide. She could not decide means we have plus minus, radical party, radical sign. Some square bees were playing cards, and they threw down 4 aces, minus 4 AC. The whole thing was over at 2 a.m. So by this story you can remember this quadratic formula, which is very important to solve the quadratic equations. Once again I tell you to watch the previous video of solving quadratic equation by factorization also, and this video also thoroughly. Thank you.